Hello everyone, it's me here. Today I want to provide you with 20 most recent and advanced research topics in economics. The first one is general equilibrium theory, which is basically the study of whether and how supply and demand can reach an equilibrium across multiple interconnected markets. This builds upon the foundational work of Arrow and Debreu, and modern research seeks to answer questions such as: what additional structure do we need to ensure the existence of competitive equilibrium? How does the introduction of incomplete markets, asymmetric information, and other frictions affect equilibrium outcomes? And what can we say about the computational complexity of finding equilibria in large economies? As a side note, this is also a hot topic in computer science. The next one is social choice and welfare economics. So this is the formal analysis of collective decision-making, aggregating individual preferences into a notion of social welfare. Classic contributions come from economists like Arrow, who explored the possibility of deriving social welfare functions that satisfy certain desirable properties, and from game. Theorists like Malan, who studied the design of voting and allocation rules. Recent research extends beyond Arrow's impossibility theorem and explores three different directions. One direction is to seek domain restrictions that allow for the existence of a welfare function that satisfies desirable properties. Another direction is to study algorithmic fairness, looking at notions of envy, freeness, and other solution concepts in matching theory. And the third direction is to look at applications in mechanism design, which brings us to our next topic. This is mechanism design and auction theory, which is all about designing the rules of a game or mechanism that incentivizes agents to report their preferences truthfully so that socially desirable outcomes can be achieved. It's essentially reverse engineering game theory, and one of the most important areas in mechanism design is auction theory, where one designs rules for allocating items to bidders based on their willingness to pay. For example, consider an online advertising auction, where an advertiser has a limited budget and wants to maximize the number of impressions given that budget, or a double-sided matching auction where students apply to schools and schools admit students. Other examples include spectrum auctions, healthcare exchanges, and many others. Next, we have bargaining theory and cooperative game theory. In bargaining theory, we study the outcomes of a negotiation between two players, whereas in cooperative game theory, we study the outcomes when players can form coalitions. For example, in bargaining theory, we may ask, what is the subgame perfect Nash equilibrium in a two-person negotiation? How do we fairly divide a surplus? What happens when the players have different bargaining powers? And in cooperative game theory, we might ask, how does the core of a game relate to its Shapley value? What is the characterization of fair allocations in congestion games? And how do we compute the core and the Shapley value in large games? These questions have applications in international trade negotiations, profit sharing in supply chains, and cost sharing in collaborative projects, just to name a few. Another interesting research area is evolutionary game theory, which studies how populations of self-interested agents adjust their behavior over time through trial and error. For example, if agents update their strategy based on the average payoff they receive from playing that strategy, then we get the replicator equation, which has been used to study the emergence of cooperation in social networks, the dynamics of language and dialect formation, and even the evolution of social norms. This is a particularly relevant topic in today's world, where social media plays a significant role in shaping opinions and behaviors. The next research area is information economics and signaling games. Information economics deals with situations where agents have private information before making decisions and taking actions. And signaling games are a class of games where one party has more information than the other. To mitigate the adverse selection problem, the informed party takes action to reveal some of that information. For example, in the classic signaling game of the moth and the owl. The moth knows better than the owl how well it can fly and decides whether to reveal that information by performing a maneuver. Applications of signaling games abound in economics, including corporate finance, where firms decide what type of debt or equity to issue. Banking, where banks signal their health through lending product quality and warranty policies. Labor markets, where workers signal their skills through education or training. And healthcare, where doctors signal the quality of treatment. The next topic is non-expected utility theories. The traditional approach to decision-making under risk and uncertainty is expected utility theory, which posits that people make decisions by calculating the expected value of outcomes. However, there is ample empirical evidence that contradicts the predictions of expected utility. People are shown to overweight unlikely events and underweight likely events. They exhibit ambiguity aversion, meaning they prefer situations where probabilities are known. They exhibit loss aversion, meaning they feel the pain of a loss more than the pleasure of an equivalent gain. All these observations can be rationalized by non-expected utility theories like prospect theory, ambiguity aversion, and others. And an active research area is to develop an axiomatic foundation for such theories. The next one is bounded and procedural rationality. Bounded rationality views economic agents as having cognitive limitations, using heuristics and learning adaptively. This research area draws from insights in psychology, sociology, and computer science to develop models of decision-making under conditions of limited cognitive abilities. For example, an agent may use a simple rule of thumb, like always choosing the option with the highest average payoff, or learn from past experiences through reinforcement. A closely related concept is procedural rationality, which refers to a situation where agents use algorithms to optimize their behavior. An example is resource rational analysis, which models situations where agents have to make a series of decisions with potentially conflicting objectives under severe time pressure. The next topic is structural econometric modeling. Structural econometric models are those where the parameters of the model have a direct interpretation in economic theory. For example, the elasticity of substitution between two goods in a Douglas utility function, or the discount factor of an agent in a dynamic optimization problem. As such, structural estimation involves not only estimating the Model S parameters, but also evaluating the Model S fit with the data. And in many cases, the parameters are not separately identifiable. This is the case, for example, in models of imperfect competition or models with unobserved heterogeneity. Research in this area often involves developing tractable approximations of otherwise intractable models or developing new estimation methods for complex dynamic discrete choice models like duration models and discrete Markov chains. And speaking of estimation, the next research topic is causal inference and program evaluation. It deals with the problem of inferring causal relationships from data. A common problem in practice is that we do not observe the potential outcomes for each unit in the population. So we can't simply compare the outcomes for treated and control groups to estimate the causal effect. This is where quasi-experimental methods enter the picture. Difference-in differences, regression, discontinuity, instrumental variables, and other methods are used to address these challenges. Recently, there's been a lot of work on refining these methods. For example, the study of invalid instruments, heterogeneous treatment effects, and A/B testing in tech firms. The next topic is high-dimensional econometrics, where we deal with datasets where the number of potential explanatory variables is large, possibly larger than the number of observations. This typically requires new estimation methods that balance the flexibility to capture complex relationships in the data with the need to avoid overfitting. Examples of high-dimensional econometric methods include lasso, ridge regression, and other variable selection techniques, as well as machine learning techniques like random forests and gradient boosting machines. Such methods have been applied to prediction and causal inference in big data sets. Next, we have network economics. The network approach to economic studies how economic outcomes are shaped by connections between economic agents. This includes the structure of financial networks, trade networks, social networks, and communication networks. For example, in finance, researchers study how systemic risk emerges in a network of interacting financial institutions or in trade. How the structure of trading relationships affects the propagation of shocks. In social networks, researchers analyze how information and innovations diffuse through networks and how social influence arises. In communication networks, they study congestion and routing problems. The next research topic is algorithmic game theory and economics of AI. With the rise of algorithmic trading and automated markets, a new research area has emerged that studies economic interactions where some or all of the participants are algorithms or artificial intelligence agents. Some of the questions this field seeks to answer include: what are the properties of algorithms as economic agents? How do algorithms interact in different economic environments? Are markets with algorithmic trading more efficient, or do they exhibit new types of instabilities? And another very important question is, how do algorithms shape prices in markets? And is that beneficial or detrimental to society? There is also a lot of interest in understanding algorithmic collusion, bias in algorithmic decision-making, and the economic impact of AI on labor markets. The next one is quantum economics and finance. This is an extremely nascent field that explores the possible application of quantum formalism to economic phenomena. This includes modeling ambiguity, disequilibrium, and entanglement between economic agents. It differs from econophysics, which uses methods from statistical physics to study economic problems, and instead, quantum economics looks at whether quantum methods can help us solve economic problems. Speaking of which, the next research topic is econophysics. Econophysics applies concepts and methods from statistical physics to economic problems. This includes kinetic theory of gases to model traffic flow, scaling laws, and agent-based modeling to study the emergence of macro-level phenomena from micro-level interactions. Agent-based models involve simulating the behavior of individual agents and studying how their interactions give rise to aggregate outcomes. For example, agent-based models have been used to study wealth and income distributions, stock market crashes, and market microstructure. Finally, the last research topic is mathematical finance. While often considered a separate field from economics, mathematical finance is deeply intertwined with economic theory and is concerned with problems like derivative pricing, portfolio theory, and risk management. It often involves solving stochastic differential equations and other mathematical problems. For example, the Black-Scholes formula for option pricing solves a partial differential equation, and the Feynman-Cach formula maps solutions of stochastic differential equations to expected values of stochastic processes. Recent research in mathematical finance is focused on modeling under rough volatility, counterparty credit risk, and other challenges associated with real-world data and high-dimensional pricing problems, where deep learning techniques have proven useful. So these are 20 most recent and advanced research topics in economics. If you enjoyed this video, please hit the like button and share with your friends. Thank you very much for watching, and I wish you all the best in your journey.